Hello everyone, nice to meet you. This is Seok Kyung-hwa from Professor Han Jong-in's lab, and I'll introduce you to the field of environmental engineering. It doesn't seem to match, but I studied economics at Korea University in my undergraduate and decided to come back to school in 2019 to study environmental engineering. So about 2 years ago, I was serious about the question that, is this research field is really worthwhile study? Because I was at the turning point. The answer was yes. So from now on, I'd like to share the core information of our department with you guys. Let's start with one question first. How important is the field of environmental engineering? Do we really need that? According to a report, the top 5 global threats are all classified as environmental. Indeed, we are already surrounded by numerous environmental problems. The first thing that comes to my mind is the particulate matter that I feel on my skin, especially in spring and winter. In addition, as plastic consumption has increased due to the COVID-19, a huge amount of plastic waste has been generated, which causes another environmental problem as it is landfilled or incinerated. And although we cannot feel it directly yet, the problem of quietly approaching global warming is also a serious environmental issue that we have to face someday. Under these circumstances, the field of environmental engineering is receiving a lot of attention. I have to say sorry to the international students for some materials are written in Korean. And this graph shows that governments continue to tighten emission regulations on pollutants, so new and more efficient technologies are required to meet those standards. And many companies are also finding a way to keep up this trend. So what I want to stress in this slide is that the future of environmental engineering is promising as the government is actively investing in the development of eco-friendly technologies. Then what are the charming points of our department? I think the biggest attraction is problem-focused learning. We first learn what problems we need to solve in a systematic way, and then learn the knowledge and skills to solve them. The second attraction is that you can experience things from micro to macro, which means you can deal with not only the small and precise analysis in the laboratory, but also large-scale experiments applied to the real world. I brought some experimental photos from our department. When developing a scrubber to remove hazardous gases, we carry out simulation analysis of fluid flow and make a prototype using a 3D printer from the small size that fits in the palm of your hand to the middle size that can be placed in our room. On a larger scale, it covers real emissions from power plants. You can even learn how to make biodiesel, that is oil that can be used for cars and airplanes, by feeding the small microalgae in the size of 10 micrometers. The last attraction is that you can contribute to solving the environmental problems by putting all of this together and making the ideas in your head into reality. Freshmen need to know what subjects they should learn, so I'll guide you on the typical environmental classes. First, you can start with the overall basic concepts of environmental engineering, such as basic chemical and microbial reactions and wastewater treatment processes. Based on that, environmental chemistry focuses more on chemistry, teaching fundamental chemical reaction, including acid-base and gas-liquid partitioning. And environmental microbiology focuses more on biology. There's also a waste management class where you can learn about technologies that can turn waste back into useful resources. Then what kinds of research is there in our field? It is divided into 4 categories. water, air, soil, and disaster. The water is the most traditional field of environmental engineering. The main goal is to purify the water we use every day so that it can be reused. In particular, these days, too many chemicals such as cosmetics, pharmaceuticals are newly synthesized and used, so the research to purify these trace substances is being actively studied. The air has recently received a lot of attention due to fine particulate matter. We have to find more effective and economical technologies to remove hazardous air pollutants contained in the flue gases as well as greenhouse gases. In the soil fields, some studies remove various toxic substances, and also some areas manage and respond to disasters using big data. In old days, environmental engineering focused more on removing harmful substances, but recently, upcycling technology that converts pollutants into useful chemicals is a big trend in all fields. Now it's time to introduce professors in our department and their research area. We have 5 professors in our department. About research area, I'll just briefly mention their topic. Professor Kang Seok-tae studies membrane filtration to remove contaminants in wastewater, and Professor Yoon Seok-hwan conducts research on purifying water using microorganisms that have manipulated DNA. My supervisor, Professor Han Jong-in, uses a scrubber to treat flue gas and simulation of how the scrubber functions on the basis of fluid dynamics. Professor Myung Jae-wook conducts amazing studies about energy production using waste plastics, and Professor Park Hee-kyung studies disaster management. Last but not least, the important part. Where can I get a job after graduating from the Department of Environmental Engineering? I investigated the actual cases. One student joined Amore Pacific, a famous cosmetics company in Korea, after graduating from a graduate school of our department, and is developing a test method to detect hazardous substances that may be contained in cosmetics. Another student was selected as an industry academic scholarship student at Samsung while attending graduate school. He's currently developing a facility to treat harmful gases in the process of making semiconductors. And the last student, who is actually right to me, went to study abroad after graduating from undergraduate school and was appointed as our professor. In addition, some are working as public officials, and also there are cases employed by Water Resources Corporation, in Korean 수자원공사, Lotte Chemical, Korean Energy Research Institute, in Korean 한국에너지기술연구원, and consulting companies like McKinsey or Bain & Company. I hope that my introduction could answer the questions of you. Thank you for listening.
Okay, thank you so much.